So I can tell you right now that this is wrong. That was our beginning slide last class. This is actually 2.3 and 2.4. And I believe it said the way the titles were actually subtraction and multiplying real numbers. So I didn't even notice that till now. So, what's that?
What is the title?
It's subtraction, 2.3, and multiplying, 2.4. So subtraction, now I'm teaching, some of this is reviewed at the beginning of Algebra 2, so I'm just doing the same thing. And they define this as the definition of subtraction. Because at this point they've already had the adding of numbers. So A plus or A minus B is like A plus negative B. That's like definition of subtraction. If you've never heard of subtraction before, I guess that might be a useful concept for you. Most of you, you're already doing it in your mind anyway. You don't need a crutch to figure that out. So I'm going to show an example. Find the difference. Again, the difference is the math word for a subtraction. So they're taking the subtraction on the left and they're turning it into an addition because we already studied addition, and then they're two negative numbers. So they add to give you a bigger negative number, or a bigger absolute value negative number. So remember, if you say negative 12 minus 19, on the number line, it started at a negative and it went further to the left to get to the negative 39. 18 minus a negative 7. You would say, well, that's plus a negative, but what is the opposite of negative 7? Positive 7. So it's almost like they've skipped a step in there of showing the plus and negative and then canceling the negatives. But we should understand that whenever you have minus a negative, that means a plus. Right? And don't leave it. I've seen before where students, let's say in a distributive property like this, something like negative 2 times x minus 3. I hope I got this right. Maybe not. Let me make it a plus here. I can't figure it out. I can't remember exactly what I'm trying to say, but they end up in an expression where they've got like a minus and negative, and try to just keep it like that and not change it to the plus. You definitely want to change that to the plus before you start multiplying by anything else. Right? Minus and negative means plus. So you just simplify that. So here's your you try. Subtract. And one of them is actually fraction. And so for the first one, they're both negative. So if you do what they did in their, previous slide, it would look like minus 2 plus negative 7. And since you're adding two negatives, it just gets more negative. And you may have gotten to this without actually changing it like that, but in one way or the other, it's negative 9. How about this one? 11.7 minus a negative 5. How should we change that? 11.7 plus 5. which is 16.7. And then how do you, okay, first of all, how do you add fractions that have the same denominator? You just add the top, right? 6 over 2. How do you add fractions that have different denominators? You got to find a least common denominator, or at least a common denominator. So in your mind, you got to be thinking, what's the smallest number that both 2 and 3 divide evenly into? 6. A lot of times, I mean, all the time, it works if you just multiply this times this. You'll get a common denominator. It may not be the least common denominator, but it will be a common denominator. In this case, 2 times 3 is 6. That's it. So now I've got to change these fractions so that they have a denominator of 6. Right? The LCD is 6. How do I make this first fraction to have a denominator of 6? Multiply it by 2, right? But if I multiply the denominator by 2 to make a 6, I got to multiply the numerator by 2. So it'll look like 2 over 2 times. And what do I have to multiply the second fraction by? 3 over 3. Okay, now what is the value of 2 over 2 or 3 over 3? 1. So effectively, we're just multiplying times 1. And what do you get when you multiply anything times 1? The same thing. So we're not changing the value here. We're just changing the form. Right? So the first term, if I multiply fractions, that is 2 times 1 over 2 times 3. That's 2 6. And 1 times 3 over 2 times 3 is minus 3 6. Again, now you could change that to plus and negative if you want. But in the end, because they have the same denominator, we're going to do like we did over here. We just subtract the numerators. What's 2 minus 3? Negative 1 6. And just to, because this comes up sometimes, right? You know, if you put it like negative 1 and the negative's definitely in the numerator like that, that's fine. But really the whole fraction is negative, right? Don't be confused if you see something like a negative and it's like right in front of the fraction bar, right? That it doesn't really have to belong to the numerator or the denominator. It's the whole fraction has got a sign of a negative. So now we can evaluate expressions that involve subtraction when they give us values for the variables. Generally, what does that mean? Substitute for the variables. In this case, they gave us an x is negative 2 and y is 7.2, and you can see where they substitute for x and y. And then it's a matter of simplification, right? In that first line, 7.2 minus a negative is changed to plus. And now you're adding up 3 positive numbers, which you could stack them all up and just add them up, right? Or you could add 2 of them and then add the third one. You get 16. So evaluate an expression. This is yours to try. Let's see. What time is it? Yeah, go ahead and do them all. We got plenty of time. Should have been negative 0.2, 10.2, 4.2. Those are the right answers. So if you, when you substitute for x and y, right, this becomes negative 3 minus 5.2 plus 8, right, which is negative 8.2 plus 8, negative 0.2, right. This one will be 5.2 minus negative 3 minus 2. Okay, what are you going to simplify in that one first? Go ahead. Ken. And that one? Yeah. So what did you do? And the first one? Let's see. But you, how did you get that 8.2? You added this and this, but they were both negative. So when you add 2 negative numbers, what do you get? A negative number. That one right there should have a minus. Maybe sometimes you get confused about, you see a minus plus a minus, or a minus minus a minus, and you're thinking like multiplication, that, oh, that's positive. We add or subtract, right? Two minuses make another minus. What operation are you going to do on this one first? You're going to do what's inside parentheses, right? So that's -5. You don't want to try to cancel the minus here with the minus here. It's kind of a distributive property thing, which we really haven't quite got to. We didn't get it yet. You probably already know it. But if you were going to use that minus inside the parentheses with the -3, you'd have to use it for the -2 also. That's just distributive property. But there's no reason to do that because we can simplify what's in the parentheses. Right? That's 5.2 minus -5, which is 5.2 plus 5, which is 10.2. And then the last one, parentheses, 5.2 minus 4 minus -3. Right, 5.2 minus 4, do what's in the parentheses, 1.2. Minus a negative, plus. 1.2 plus 3, 4.2. Okay, so example. One of the most extreme temperature changes in United States history occurred in Fairfield, Montana on December 24th, 1924. At noon, the temperature was 63. By midnight, the temperature was -21. What was the change in temperature? What's the operation we have to set up to figure out what's the change in temperature? What was the temperature at noon? 63, right? What was the temperature at midnight? -21. What do I have to do to those two numbers to figure out how much it changed?
Subtract them.
You're going to subtract them. Minus -21, which is going to make it like 63 plus 21. That changed 84 degrees Fahrenheit. If you look at it on a number line, right? Here's 0. Here's our plus 63. And here's our minus 21. So it went from here, which is 63, absolute value, to here, which is 21. So these have to be added together to give you the total, 84 Fahrenheit. You know, and in that part of the country, it could change really quickly because you get the coldest air. You know, where do you think the coldest air comes from? It comes from Canada. Where do you think it comes from to get to Canada? Siberia. Okay, it's usually the place that is the breeding ground for the coldest, driest air on the planet is Siberia. And because of the Rocky Mountains, you know, that air doesn't like travel from the west to the east, because if it did, it would go over the ocean, it would become moderate and moist. But when it comes over the pole, it's still cool and dry, and it can really cause big changes in temperature. I mean, that's why we get, you know, in America, we get more tornadoes than the rest of the world combined. Because we've got that source of cold, dry air coming over the pole. We've got warm, moist air coming from the Gulf of Mexico. And we've got the Rocky Mountains, which is blocking anything that might be kind of moderate air coming from the west. So you try to do this one. A new car is valued at $15,000. 1 year later, the car is valued at $12,300. What is the change in value? I mean, I think a lot of you probably did it in your head. But just remember the process for subtracting numbers. Right? If I'm subtracting 15,000 minus 12,300, right? 0, 0, 0 minus 3. You know, 0 is less than 3, so generally we're going to borrow. 10 minus 3 is 7. 4 minus 2 is 2, and then another 0. 2,700. Okay, what's wrong in these two calculations? First, start on the number 15. Spot the air. Yeah, it should have been minus a -8 on the first line, right? There was a minus in the equation, or in the expression, and the number was minus. So it should have been minus a negative, which would have made that a +8. So there's the mistake. What about in the number 16? Spot the error. Say again? Where? Okay, so look on this line here. 3 minus -12, and the next line says 3 minus 12. What should it have said? 3 plus 12. Okay, the sign of a product. This moves to the next section, 2.4. The product of two real numbers with the same sign is positive, right? So we know that positive times positive, or negative times negative, is a positive number. The product of two real numbers with different signs is negative. So a plus times a minus is a minus. Whether or not you switch the order, it's still negative. Right, there's a couple examples for you there. So here's a few examples. The first one is a negative times a positive, so it should be negative. -3 times 6. I mean, in your mind, you're just doing 3 times 6. Multiplication tables time, right? 18. Put a minus on the front of it. Right? The next one, what's the sign going to be if it's a positive times a negative times a negative? We're multiplying 3 numbers together now. What's the sign going to be? I mean, you just add up the negatives, right? If there's an even number of negatives, it's going to be positive, right? The -5 times -4 is what? Positive 20. So that's 2 times positive 20, which is 40. Now, they didn't actually they did theirs like this, right? They did these two first to get a -10, and then negative times negative is positive. And the last one's got 3 negatives in it. So how many, is this going to be positive or negative? It should be negative, right? If it's an odd number of negatives, it's going to be negative. You could see, what did they simplify first? They did the -1/2 times -4, which is, the negatives will cancel, and then you're taking 1/2 times 4, which is 2, right? So positive 2. Now, 2 times -3 is -6. Easy stuff, right? You say it's easy stuff, but it's the source of so many mistakes in algebra. So many mistakes. So go ahead and try this. So the first one was a negative times a negative, so the answer is going to be
14.
positive 14, right? The second one, the -0.5 times -4. Well, first it's a negative times a negative times a negative, so what will the result be? It's going to be a negative, right? The answer will be negative. How do you simplify with the 0.5 multiplying? I mean, 0.5 is like 1/2, right? So it's like saying, what's 1/2 of 4? 2. I mean, if you have to multiply it, you can definitely multiply it. 0.5 times 4. 4 times 5 is 20. 4 times 0 is 0. 2, because the decimal place was over 1, it's over 1. So now we've got 2, that should have been positive 2 times -9, -18. And then the last one, many are having trouble with that. This is what you should do when you see something like that. Okay, 3 in the denominator cancels 3 in the numerator. And all that's left is the 4 and the negative and the 7, which is -28. Okay, when you see, some people, they multiply to get -12 over 3 times 7, which is not incorrect, but it's, and at that point still, then we're multiplying 12 times 7 to get -84, and that, at the very least, you would simplify 12 over 3 as what? It's 4, right? So it'd be -4 times 7. But when you have fractions, you can cancel factors in the denominator with a factor in another fraction in the numerator, as long as they're all being multiplied together. Because in the end, how do you multiply fractions? you're just going to multiply everything together anyways and put it in the same numerator and denominator. So definitely you would try to simplify what you could. Cancel the 3 with the 3, and that's negative 28. Okay, getting there. So now we have properties for multiplication. And you could see 1, 2, 3. The first 3 are kind of like what we had with addition. There is a commutative property, which means order doesn't matter when you multiply. There's an associative property that says grouping doesn't matter when you multiply. There is an identity property that tells us what we can multiply times a number to get the same number back again, which is, what number do you multiply by to get the same number? 1. And so 1 is called the identity element for multiplication. Now, the next 2 are not. We don't have anything like this in addition. And especially the property of 0 is so important in math. The 0 property of the property of 0 for multiplication is, if you multiply anything times 0, what do you get? 0. Okay. Now there's ways that you can see this. I mean, this is where it usually comes up, where it becomes so important. What if I'm multiplying two numbers, and I'm just going to use variables, a times b, and the product is 0? By this property, the only way that could happen is that either a or b has to be 0. That's how you make a 0 with multiplication. You multiply by 0. So that's how we end up solving more complicated algebra equations, is that we use the property of 0. I mean, it does, we would start with something like this and say that means that either a equals 0 or b equals 0. And we solve those smaller equations. Another thing to keep in mind, I'm not sure if it'll come up again, but I had this come up in Algebra 2 the last couple days, where people were solving things and they got to the point where it's 0 divided by 6, which is like saying 0 times 1/6. What is that? 0. It's not undefined. It's 0. 0 is a number, right? It's right in between positive and negative numbers. It's not undefined to have a fraction with a 0 in the numerator. It's like I say, if you've got a pizza and you divide it into 6 equal slices and I give you 0 of them, how much pizza do you have? 0. 0 over 6 is okay, right? It's 0. So here's their examples of properties, right? The first one is associative. All we're doing is moving the parentheses, and that shouldn't change the value of anything. The second one, 8 times 0 equals 0. Multiplicative property of 0. The third one, change the order. Commutative property. We didn't talk about that last one. The property of -1, right? When you multiply something by -1, it changes the sign. No, and we will get to a point, I don't have a good sense of how much of this you've had, because in pre-algebra they actually go a little bit into algebra, but you know that when we do things like 2x equals 6, we divide both sides by 2, x equals 3. If you have something like -x equals 6, sometimes people think, well, I'm going to divide by -1. But really the multiplicative property of -1 means just multiply by -1. And you can do either one you want, but most of the time, I'm always going to multiply by -1 to change signs. And the last one, 1 times v equals v, identity property of multiplication. Let's see. So you go ahead and, oh no, this is just me doing an example. This is kind of the typical way they ask us these questions on SOLs to justify steps. Notice what they're doing on the left, right? On the first line, there's a left-hand side and there's a right-hand side. What's the difference between those two? How did they change the left-hand side to get to the right-hand side? They changed the order. So the justification would be commutative property. Okay, what did they do from the first line on the right-hand side to the second line on the right-hand side? Right? Understand that this -4x, that's a multiplication, right? There's a -4 times x. So what did they do to get from first line to second line? They moved the parentheses over, but since the -4 is in parentheses itself, they use square brackets. Okay, and now 0.25 times -4 is -1. Not really a property that's in our list, and actually most of the time they do something like that, they would call it substitution. When you're just saying what something equals, they didn't use the word, but they kind of explained it. And then -1 times x is -x. Multiplicative property of -1. And that's it. So we did, again, this was a not that, this was a subtract, which was 2.3, and this was a multiply, which was 2.4. And the homework is